Newton's third law states that every action has an equal and opposite reaction. A great example of Newton's third law can be seen in tractor pulling. Tractor pulling is a motorsport competition which requires modified tractors to pull a sled along a 300-foot track. The size and weight of the sled is dependent upon the determined weight class. The winner of the tractor pull is determined by who pulls the sled the farthest. Here's an example of a tractor pulling exhibition. In the video, the mass of the sled behind the tractor is noticeably greater than that of the tractor pulling the weight. However, the force exerted against the ground by the tractor is enough to overcome the static friction holding the sled in place. When the tractor pushes against the ground pushes back with an equal and opposite force, accelerating both the tractor and the sled in a forward direction. Let's watch the video again, keeping Newton's third law in mind. In regards to Newton's first law, which states that objects in motion tend to stay in motion, as well as objects at rest tend to stay at rest, a force was necessary to move the sled, which wanted to stay motionless. Static friction was holding the sled in place until a greater force acted on it, moving it forward. As we learned in Newton's second law, the force acting on the sled to overcome the static friction is equal to the mass times the acceleration. Now that we can apply Newton's third law, we can see that the reason the sled can be moved is because of the force of the earth pushing back on the tractor is enough to overcome the static friction, keeping the sled in place. This is how powerful engines can move objects that are much heavier than the engine itself.
Wobble, 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 I'm stacking my paper. My wallet look like a